Okie dokie. So a student named Chase sent me a bunch of good word problems, weirdly worded problems, and he was wondering how to approach them, which equations to use, etc. So here's 9 problems related to compound interest. Let's get into it. So so-and-so contributes $6,500 a year. How much will he have in the account after 35 years if it grows at 5.5 a year compounded yearly? So the question you want to ask yourself is like, are they putting in a lump sum at the start, or are they constantly contributing like periodically? And in this case, it's periodic payments. They're making $6,500 contributed a year. And so we want to use a future value of the annuity formula because their regular payments are $6,500. And I'll go ahead and write the actual formula here. It's capital R, 1 plus R over M to the MT minus 1 all over, that's supposed to be R over M. All right, so yearly payments, $6,500. 1 plus the rate, which is 0.055 as a decimal, and compounded yearly. So the nice thing is really you're just dividing by 1 there, and then to the MT is just 1 times 35. So R is the rate as a decimal, M is the number of times per year, interest is compounded, and T is time in years. We subtract 1, we do R over M here. Whoops, that should be 0.055 over 1. And plug that into Desmos, calculate that, that's it. Okay, I'm going to give you the setup, so I'm not going to calculate it, waste too much time. Number 2, Lauren plans to deposit $5,000 at the beginning of next month and then $250 at the end of each subsequent month for the next 7 years. If her bank pays 5% compounded monthly, how much will she have at 7 years? So the question is, do we have a lump sum or do we have regular payments? And to answer that, the answer is both. They're depositing a lump sum at the start and they're making monthly, periodic payments. So we have to use 2 equations. We're using first just regular compound interest that's compounded multiple times a year, and we're using the future value, which I wrote up here. So I'm not going to write it again. Starting with this one, the amount that the $5,000, the lump sum, will grow is going to be calculated with this. So M is monthly, it's compounded monthly. So M is 12, and then M is 12, and then T, time in years, is 7. Calculating this will tell you how much the 5,000 has grown to. And then calculating future value with the 250, the periodic payments, will tell you how much, that's contributing to the account, how much that's growing interest, etc. So it's pretty much like the same. Like you can see this equation within this equation, which is kind of fun. It's just different, lump sum payment versus subsequent payments, periodic payments. And you might ask, like, well, why is this accurate if you're adding money to it, and then so it's adding interest? Don't worry about it. It's all percentage based. This grows a certain percent, and you're already calculating all the percent that the 250 over and over and over again is growing using the future value formula. So you calculate both of these, A and FV, for the 5,000 and the 250 payments, and you just add them together. Okay. Number 3, a bank deposit paying simple interest grows at a rate of 6 per year and grew to a sum of $1,300 in 8 months. Find the principal. Okay, let's word it like this. Simple interest. Let's start with just the interest. Interest is P times R times T. The principal investment times the rate times time in years. The accumulated amount is just the principal plus the interest, okay? And so they say it grew to a sum. The accumulated amount is $1,300. So we know that $1,300 is equal to P plus I. And I'll go ahead and say I is PRT. Okay, so we're chipping away. We are solving for P. We're solving for the principal. So we can plug in 6% and we can plug in 8 months. So what I'll go ahead and do, I'm going to factor out a P. So it's going to leave us with 1 plus R times T. And then I'm going to actually plug in the R and the T. So the rate is 0.06 for 6%. And T is not going to be 8. I know it's 8 months, but it's time in years. So it's got to be 8 over 12. So 2/3, however you want to see it. And so then we're going to calculate this, and then to get P, you're going to divide that stuff to the other side. So it's going to be 1,300 over 1 plus 0.06 times 2/3. Okay, so if you calculate that, that's your principal. That was number 3. Here's number 4. How many days will it take for a sum of $2,000 to earn $24 interest if deposited in a bank paying simple interest at a rate of 6%? Again, simple interest is P times R times T. And so we want to know how many days it'll take to earn $24. Okay, interest. So basically they want the interest to be 24 for an initial investment, principal investment of $2,000. The rate is 6%. And really we're solving for T. And so again, this T value, solving for T, will give you time in years. And so let's go ahead and work this one out just because it's quick. 24 over 2,000, okay. So what this gives you is 0.2. So we get 0.2. So you might ask yourself, like, what does that mean? Well, that's time in years. So the question is, how many days are there in a year? Well, there's 365. So just multiply this by 365, and you get 73. So time is 73 days. That was just converting 0.2 years into days. So it'll take 73 days to earn $24 interest. Number 5, find the effective rate corresponding to the given nominal rate. 5% per year, compounded quarterly. So the way I see this is kind of using like just the compound interest formula that's just like this. Like really just use this part of the formula. That's how I see it to calculate the effective rate. So it's just 1 plus 0.05 over 4 because it's compounded quarterly, and then to the 4, and then you can just think about it as like the time in years is just 1. So really you could just knock that off. Yeah. So that's what we're calculating. Calculating this, I think it tells you just like what the interest is like every single time or something. It's like, and I think maybe it gives you the actual yearly. No, I guess that's 5%. Yeah, it gives you like the whatever the amount it's compounded like every. You know what? Let me calculate it because I think there's like one extra thing I have to mention because it's gonna have the 1. So it's gonna be 1 plus 0.05 over 4, and then to the 4th power. So okay, yeah. So notice, this is not the interest rate, but if you subtract 1, maybe that's an important part. Yeah, maybe, you know what? Yeah, I'm gonna say we subtract 1. So really it's more from like the annuity part, the annuity formula, where you do want to subtract 1 if they're asking for it, because we don't want to leave the 1 tacked on. We want just the 0.050945. 0.050945. And so as a percentage, that's 5.0945%. So that's the effective rate. And I think it's like, I don't know. I can't define it, but I know that's it. Okay, number 6. Isabella purchased 20,000 worth of 13-week T-bills. I think that's supposed to be T-bills. For 19,600, what will the rate of return? What will be the rate of return on her investment? Okay, not 100% sure on this, but I think it's just the idea that like your 19 is growing to 20,000, and I mean the way I'm gonna see it is I might just treat it as like an initial investment type of thing. So we're solving for the rate. The compounding, I don't think we even need to see it like that. I mean, it's just going to be 13 weeks. This is so crazy. Okay, I'm going to do 13 weeks over 52 weeks. And then just solve for R. Hope that's I don't know. This is a weird problem. I would not expect this problem on the exam, but who cares? Let's do it. So, let's keep going. So 20,000 over that. So we're going to divide by 19,600. And then we're going to get crazy. Okay, let's get that first. Hold up. So we get 1.020408, etc., equals 1 plus r to the 13 over 52. So we're going to have some fun with this. I'll be honest, I do not know if this is right, but I think it's probably right. We're going to get r by itself, so we're going to raise this to the 52. 52 over 13 to eliminate that. And then we're going to subtract 1. I guess 52 over 13 is 4, isn't it? Yeah, that's cool. Okay. Anyway, we get this, and then we're subtracting 1. That seems like a reasonable value to me, so I'm going to call it 8.41%. So we get 0.0. So again, I raised this, and then what we had was 1 plus r. So then I subtracted 1 from that to get r by itself. So I got r was 0.08. 417, and so that's 8.42%. Again, I wouldn't worry about this one, but it's a cool one, I guess. All right, here we go. So just to talk about this one a little bit more, I think it's the idea of like you're investing 19,600. It'll eventually grow to 20,000. But over the span of 13 weeks. So I guess the interest rate is 8.42 that allows it to grow that fast. That's the idea. Find the periodic payment R required to accumulate a sum of S dollars. Okay. So we're accumulating a sum from no, the sum is 45. Okay, yeah. Periodic payment. Okay, so once again, it's like, are we doing a lump sum or are we doing a periodic payment, capital R? And we are doing periodic payment. And so we want to use the future value formula because we are accumulating a sum of $45,000. So we're using FV equals R, capital R that is, 1 plus lowercase r, which is, oh, no, I'm sorry. Okay. I mean, okay, and this might have been just a copy-paste issue, sorry. This is meant to be lowercase r. They ask us to find the periodic payment r. Yeah, that makes sense. Okay, so the rate being 4 means 4%, which means the decimal is 0.04. You're dividing by m, which is 4. You're raising it to the m times t. Subtracting 1, dividing by 0.04 over 4. Again, for time's sake, I'm going to keep it moving, but what you would do is calculate all this and then just divide 45,000 by that. Capiche? Okay. So yeah, just calculate this, and that'll be your periodic payment. All right, let's keep it going. Number 8, suppose payments were made at the end of each month. Ordinary annuity, they're telling you what it is. Interest at a rate of 2.5% compounded monthly. If the future value is this, what was the size of each payment? Same exact problem. So the setup would be, they say the future value is 70,000. They're asking for the size of each payment, which is capital R. And then 1 plus the rate, 0.025, very small, over, I guess, yeah, okay, compounded monthly, that's 12. 12t, which is 10 minus 1 over r over m. So again, calculate this whole deal and then do 70,000 divided by that to calculate your r there. Again, we know we're using this formula because it's ordinary annuity. This is the future value of an annuity. Keywords there, okay? And regular payments. That's why. All right, so bank loan, 312. I'm going to go ahead and say anytime they're talking about like taking out a loan and making monthly payments to pay off the loan is like a present value formula, like present value of the annuity type of formula. Because the idea is like the present value, the money you take out is 312. By the time you've paid that off though, plus interest, the paid it off plus interest amount is your future value. Okay, so the bank charges this rate, interest compounded monthly, 25 years. What should the size of each repayment, what should be the size of each repayment if the loan is amortized at the end of the term? So you're making monthly payments, and eventually it's kind of weird to say it like this, but eventually the present value would be 312. No, it's probably easier. It's best to think about it as the present value is 312. So it's like, what would the monthly payments be so that you're covering the principal, but also the interest that's accruing over 25 years. That's the best. I just crushed it, and I don't remember what I said. But PV equals R times 1 minus 1 plus R over M to the negative MT over R over M. So very similar to future value, but you get the 1 minus and you get the negative exponent. So calculating, again, monthly payment, you're calculating the R. So you just plug in everything in. 1 plus R over M, so 0.02 over 12 for monthly payments, negative 12 times T, so 25. R over M. And then solve for R by doing this divided by that. So that everything in the parentheses here. So that's pretty much it. That's the setup. I hope this helps. These are extreme word problems for the most part. I could maybe see 1 or 2 being on the exam. Nothing too crazy though. The biggest thing, again, ask yourself whether interest is growing. Are you making a lump sum investment, or are you making periodic payments? Because that makes the difference of like using this formula versus, say, future value investment formula. Anyway, this is a little taste of weird word problems. I hope this helps. If you have any questions, please let me know. Okay, bye-bye.